So this is our setup. We have a speaker, and then we have half of a styrofoam cup, and then we have a mirror attached to the top, which we shine a laser on, and then when the low frequencies resonate through this, it reflects back onto the wall, making big patterns. The first thing we needed to do was to find the wavelength of the guitar. We did this by taking 2 times the length of the strings. The next variable we had to find was the frequency. We did this by Googling the frequency of a low G on a guitar on Google. Next, we plugged in both of our variables into the equation for velocity, taking wavelengths times frequency. To find energy, we Googled the frequency of red light and took it times Planck's constant, 6.63 times 10 to the negative 23rd. We then found the energy. Another thing we could do with the light was to find the height of the image. The image produced can be found by setting up a proportion, leaving us with 0.04 meters as our height of the image. Due to us having a plane mirror, we know that the angle that we reflected the light at it was the same angle that it refracted back and shined on the wall. We also know that light travels as a wave and hits as a particle. Sound travels in waves, and the different characteristics produce different interpretations from our ears. The sounds of a guitar travel in transverse waves. Amplitude is how much the wave differentiates from the normal. The more amplitude there is, the louder our ears interpret the sound. Wavelength is length from trough to trough, note to note, or crest to crest. Note is a region where the waves cancel each other out. The crest is the place of highest displacement, and the trough is the place of lowest displacement. The waves in a recorder would look a little different, however, making things that look more like the diagram shown.